Hi, welcome back to my channel. This video is in response to a comment I got on my last video about the future of the channel and some of my background. And it was a very good comment, so much so that, again, I decided to make a whole video about this. Was basically the essence of the comment was, well, if you're trying to make your content potentially be more popular, then why don't you use programming languages that are more popular? And that's an excellent point. And I thought a lot about that because one of the things I thought about was indeed, actually, maybe I should do that. And then I decided, well, I might actually be more motivated to just kind of keep doing what I'm doing. And the reason why is that what I think is interesting about the kind of current computing world and stuff like that is how people program now versus how what I was used to, and how people can become better programmers. And that's what I'm really interested in, is trying to provide some information about how people can learn more about the languages that use in an abstract way versus, oh, just here's some 50 or 60 hints on how to use C sharp, which I could do, but there's also people out there that probably do a much better job of it than me. And so here's the thing that motivates this. A lot of people now just learn a programming language. I mean, they may have had to use some other programming languages in school, but they really seem to gravitate to a single language and have a hard time understanding anything that is outside that language. So much so that some of them get dismissive of anything that really isn't well supported in that language. I think the best example of that right now is a lot of the skepticism from a lot of the people in the web and TypeScript programmers around object-oriented programming, just because TypeScript really doesn't do a good job of object-oriented programming. A lot of the frameworks around React have kind of shied away from using class-based ideas, and so they're fundamentally kind of dismissive of them. Even saying it's kind of, oh, that was a mistake. Sometimes sometimes tongue in cheek, sometimes very seriously, as if object-oriented programming was basically this 90s 2000 thing that just led to bloated code, and not really understanding how these other languages worked and how you want to do these types of things. And it was one of those things where if you look at the ecosystems that we're in right now, um, people would argue that they're not really motivated by that. They're motivated by, well, we want to reuse code. But the reason that people use Node is really out of a desire to not have to program in any other language. And not just a desire, but an inability to program in another language, despite the very, very real limitations that taking something that was hastily designed for a very specific environment and try to apply that to general programming problems has. It's just that people are so ingrained in wanting to be able to do programming in TypeScript and run it everywhere. And that comes out of not this, well, we're going to get this major reuse out of code and we don't have to do simple things on the code and server. It's really out of this inability to learn any other programming language, or even switch between one language or the other. And there are plenty of programs out there that can do that and will do that and actually enjoy doing that. But for all of those projects, there's people that are increasingly shoehorned into just doing one language. And so the interesting thing about that is that I think that has an overall impact on the quality of the work that they do. I don't think it's as good. I don't think they have the abilities to adapt and change during their careers, which means that if they get kind of pigeonholed as a front end engineer, that they'll never be able to switch into anything else. And not only that, but just in general, as a user of software, I can see this impact that it's increasingly having on the software I'm using day to day. That, less and less people know how to use these other types of tools and dismiss them. And that means software like on the desktop, and in some cases, even the mobile space, really suffers. So one of the things I think about that is the way I think that you can fundamentally break through that problem is that you can really learn what the fundamentals of programming language is and understand how most programming languages are just basically variations on a theme. And if you engage with the concepts behind programming languages, or what some people call programming language semantics, you can really create better code, and you're going to adapt to changes in the environment better. You're not going to feel so threatened by things changing underneath you. And not only that, but your overall software if your software quality is going to improve because you can use the tools best suited to the task versus trying to force the one tool you understand to meet the needs that it can't necessarily meet. And so where does Racket come into this? And what Racket really does is that it breaks down a program language into its essentials. There's very little syntax. There's almost no syntax whatsoever, right? Um, and not only that, but there's very few built-in concepts into Racket and Scheme, really. You'd be surprised at the vast majority of what other people would call keywords, right? Or these built-ins are actually just built on these more fundamental concepts in Racket. And what that does is that means you can really build up your own versions of the language that do slightly different things very easily. And not only that, but it really reduces amount of what I call ceremony to the bare minimum. And you can start really looking about how you can build these blocks together to really understand how languages and programming languages work. Not just in terms of, how they ultimately can compile down into something that runs on machine code, but more importantly, how you can abstract about these programs and what they do without thinking about how they run on the machine, which can be a very, very, very useful way for getting programs to actually work. And the thing about it is that what this does is that because it has a small surface area, you can look and learn a lot about programming in the small. Racket programs can be very concise, and they can have very useful examples that are a page long, if not, or more, and not much more than that. And it's because you have minimal syntax, and sometimes you can just get to the point very quickly. I have talked more about these books, but if you take a look at the books like The Little Schemer and The Season Schemer, you can see how these very small snippets of code can really show fundamental ideas very, very clearly because it's just distilled down to the essence of what they're trying to talk about. And again, it's one of those things where Racket makes meta programming very easy because, Racket programs are lists, and the fundamental data structure in Racket is a list. And so you can make lists. And so you can make programs as easily as you can make a list. And you can parse up programs as easily as you can parse up a list. And that leads to all sorts of opportunities about how you do things. And again, when we are programmers, sometimes we want to understand things by writing programs about them. And so if we want to understand how to, more about programming languages, it helps to be able to write programs about programming languages. And Racket is uniquely designed to make that as easy as possible. And if you look at any other languages you would try to do that in, there's certain places where it is possible, but because of the syntax and how they work, it's so much more difficult to do metaprogramming than it is in Racket. And metaprogramming and the ability to be able to think of code as data, data as code, and how they work back and forth with each other can be a fundamentally empowering concept that really helps you get to the next level of competence in your overall programming career. And also, again, I'm going to go back to this, but the very small amount of the fundamental concepts makes it easy to make a very small but still working version of the language. I would say that if you wanted to have a professional project that was going to stand out for the very rest, would be take your favorite programming language and make a very small REPL, which is read, evaluate, print loop for that Racket. Again, the parsing is not going to be too difficult to do. You don't have to have a lot of functions. And you can be surprised how far you could go if you just did things like, I'm going to have basic Lambda support and be able to have higher order functions and named functions. So I think that's an amazing project. And it's not going to be nearly as hard as you would think. Once you really understand just the very few fundamentals and how you need to do them, implementing them in another language would be fairly straightforward. Now, some people ask me, and this comes up a lot, is like, well, if you're going to use an exoteric language, why don't you use Haskell? And the reason being is that Haskell has a very different goal than the one I'm interested in, which is basically understanding the essence of programming languages from these fundamental building blocks. Haskell is very much about showing how taking a very opinionated view on strongly typed pure functional programming and implementing in the language leads to more correct programs. And basically what it is that Haskell does argue, and some people agree with it, some people disagree with it, but basically that there's strong type checking and their basically opinionated enforcement of how you do certain types of things does make it so that it is much more difficult to make programs that are fundamentally not correct. And this leads to a lot of arguments, of course, what it means to be correct and how useful that actually is in practice. But it really isn't as useful for someone who's more of a beginner. Haskell is not a language that is approachable by beginners, to be perfectly honest. Um, you have to go through and really train someone to use Haskell from the very beginning. And I would argue that that would be a much more difficult thing to do than having a similar curriculum based on Racket. So again, I don't want to dismiss Haskell as just being, this, they're out of these world academics that just don't get things, but um, they just have a different goal than the kind of things I'm interested in and the kind of programs I want to write. So finally, one of the things that learning about programming language semantics does is allows you to think outside the machine. Now, there's a lot of value in understanding how code is compiled and executed in hardware. I think more people have should be taking compiler courses and things like that. And I wish more programs had made compiler courses mandatory, like they were when I was doing a CS degree, my bachelor's in CS. But something has to give, and some things have to become electives, or only people are interested in. But there's also a lot of value, and I would also argue maybe even some more value now in understanding how you have a mental model of execution of a program and what it does that's independent of, oh, here's what a CPU does, and here's the memory layout. And those seem contradictory, but they're really not, because there's certain types of things where if you don't understand that large picture and how things are interacting, then you're going to make no headway by looking about how they're implemented at a lower level. And I can think of things like, concepts that you see now, like promises and futures and non-blocking APIs, these things like that. It really helps to have a model that is not tied to, oh, well, this is basically because we have multi-threaded and multi-core things that's doing all this and all this in the stack. That can be really difficult to understand if you don't understand, oh, here's how these promises and ideas and all this could work, even if you didn't have multi-threads and CPUs and cores and stuff like that. What does that really mean? And Racket actually has some very interesting things built into it that allow you to do things like that. They do have a futures library and a promises library, and they are coming out with some even more interesting stuff around parallelism in the next version of Racket. I'll talk a little bit more about that in the next slides. And finally, one of the things about it is that hopefully by engaging with some of this stuff, it gives you a way of thinking in another box. And I think that's really one of the things that can help somebody who's maybe going on in day to day, just doing the same thing in the same language and thinking that they're kind of caught in this endless treadmill, is to be able to solve some simple problems or fun problems using a completely different language that you enjoy. And that can be really refreshing and can really help you, get through the day to day better. And certainly I've, gotten some use out of, solving these problems in terms of, engaging with my brain and feeling a little bit better about myself by solving some things. And the nice thing about Racket is that it's not too demanding of you. You don't have to take Racket programs that seriously. If you can type them together, you can make them evolve. If you're learning something from them, that's great. It's okay if you throw it away. You're not building something that's production quality. And it's not that you couldn't do that with Racket. I don't want to lead people astray, but Racket is more than fine to let you just explore and do stuff and, do things and just, interact with the environment and experiment. And I think that's one of the things that's really nice about the environment is you can just go off and do interesting things about it and not worry that you're making this huge investment in tools and writing all this stuff that you don't have to write, and you don't have to feel so precious about it. And that makes it actually kind of fun to use. So again, maybe try making a bit of a Racket yourself. There's I use Dr. Racket because there's some tools in there I like, but there is great support for Racket in VS Code as well as Vim and Emacs. So whatever your favorite editor is, there's going to be support for Racket in there. And there's going to be some interesting features coming to Racket 9 that are going to be really kind of fun. And I'm looking forward to showing those off in some of my slides, some of my videos on the programming language. And not only that, but they're really great people, great community to interact with. I've had some great conversations with people there as well. So anyway, thanks for watching. And hopefully you'll be seeing some more videos about Racket from me soon. Thanks. Bye.